What if you had the option to use nuclear waste to power your devices and you never have to recharge your batteries ever again because these new batteries might last up to 28,000 years? Yeah, that's right. Almost every electronic device that we use today uses batteries, but the problem is we have yet to discover a new revolutionary battery technology that might change the way we store and use energy. This is also important in a day and age when we're switching from gasoline to pure electric vehicles. Yes, electric vehicles might need the most advanced batteries, but every other device that we own is no exception. Most of the batteries that we use today are lithium-ion based, and it does come with its own fair share of issues, even though these batteries are the best that we have today. Batteries are just one end of a huge process of energy production, storage, and distribution. Nuclear energy is touted as one of the cleanest forms of energy when you take into account the carbon emissions. But the problem with nuclear energy is the highly radioactive waste that is being generated. We now have a solution for both battery technology and also for the disposal of nuclear waste with a nuclear diamond battery. Wait, are we going to create a battery with diamonds? That would make our devices expensive, right? Well, in less than 2 years, you might be able to buy a smartphone that is powered with a radioactive diamond battery, and this battery is not your average battery. It might even outlive you and your future generations. We already produce enough hazardous radioactive waste that is incredibly difficult to process and get rid of, even though nuclear power is considered to be a clean energy source, all thanks to its zero carbon dioxide emissions. This is when a group of scientists took it as a challenge to come up with a solution to deal with nuclear waste and also revolutionize battery technology. Because this is the need of the hour considering the fact that the world runs on batteries. It all started back in 2016 when a group of researchers, physicists, and chemists at the University of Bristol started working on what is now known as radioactive diamond batteries. The battery they came up with was presented as a beta voltaic device, which means that it is powered by the beta decay of nuclear waste. Now, if you don't know, beta decay is a type of radioactive decay that occurs when an atom's nucleus has an excess of particles and releases some of them to obtain a more stable ratio of protons to neutrons. This produces an ionizing beta radiation, which involves a lot of high-speed and high-energy electrons or positrons known as beta particles. A typical beta voltaic cell consists of thin layers of radioactive material placed between semiconductors. As the nuclear material decays, it emits baser particles that knock electrons loose in the semiconductor, creating an electric current. However, the power density of the radioactive source is lower the further it is from the semiconductor. This means that the nuclear batteries are much less efficient than any other batteries that we have today. To solve that, we have polycrystalline diamonds. You see, radioactive batteries are made through a process known as chemical vapor deposition, which is widely used for artificial diamond manufacturing. Researchers have modified this process to grow radioactive diamonds by using radioactive methane containing the radioactive isotope carbon-14, which is found on the irradiated reactor graphite blocks. These diamonds will act as a radioactive source and as a semiconductor when exposed to beta radiation. As a result, you get a long-duration battery that does not need to be recharged. The nuclear waste in its interior fuels it over and over again, allowing it to charge itself for ages with little to no measurable degradation over hundreds of years. This means that in theory, a single battery can be used to power over hundreds of years without having to be replaced or recharged. Now we already have a company that is already working on these batteries. A San Francisco-based startup, Nano Diamond Battery, is promising a high-powered diamond-based alpha, beta, and neutron voltage battery to give the devices longer battery life. These batteries make a lot of sense for devices whose batteries are extremely difficult to replace, like a pacemaker or a space rover. As of now, these are just ambitious goals for the Nano Diamond Battery. But is it actually possible in reality? Well, to understand this, you need to look at the batteries themselves. To build the Nano Diamond Battery, the company uses layers of impossibly tiny paneled nanodiamonds about 1 nanometer, which is about 1/1000th of a meter. Yeah, it's that thin. Diamonds are perfect because they have exceptional heat conductance, which makes them ideal for electronic devices. They're also some of the best known natural conductors of heat, as they are at least 3 to 4 times more effective than copper or silver. Scientists will be cultivating these miniature diamonds using chemical vapor deposition, which is a process in which gases at extremely high temperatures force carbon to crystallize on a substrate material. This process creates a cost bottleneck because making these special diamonds are extremely energy intensive and not so easy on the pockets. True blue diamonds are naturally occurring on Earth, but they're extremely rare and even more expensive than artificial blue diamonds that would be used for making these batteries. All these diamonds are blue because of the trace amounts of boron contained in their carbon structure. These blue diamonds are artificial, but are also reminiscent of true blue diamonds, which are already some of the rarest gemstones that you can find on our planet. The naturally occurring ones are formed in the Earth's lower mantle, which is about 410 to 1680 miles below the surface, and are only available in 3 major mines in the entire world, making the naturally occurring blue diamonds extremely expensive. Once the company sources the nano diamonds, they then combine them with radioactive isotopes from nuclear waste. They use radioactive isotopes of uranium and plutonium, which already come from radioactive power plants waste. Then, single crystal diamonds just a few square millimeters in size move heat away from the radioactively decaying isotopes so quickly that it actually generates electricity. The decay sources deposit their energy onto the NBD transducer, which converts the kinetic energy of the incident radiation to electric energy. Now, you might be wondering if there's a diamond battery that can use nuclear waste and also last for several years. Wouldn't this be the next big thing for electronic gadgets and electric vehicles? Well, the devil lies in the details. Each battery cell will produce only a small amount of energy, so cells must be combined in huge numbers in order to regularly power large devices, raising the cost by a huge margin along with increasing the complexity. The tiny size of the nano diamond battery cells can be touted as an advantage for scalability, especially when you consider gadgets like a wristwatch, which consumes only 2 microwatts. So a smaller nano diamond battery would be sufficient, but there's still the issue of wear and tear. Researchers implant the nuclear waste inside the diamond cells, which creates a natural structural weakness, which means it will eventually fail. Over time, when nano diamond batteries become widely available in the future, there are chances that some of the cells will break or simply go to waste with the devices that these were intended to work with. This might create more nuclear waste if these batteries become mainstream. If these batteries are used in space, it might not be a big problem, but if used on the surface of the Earth, it might result in so many catastrophes. But this does not mean that diamond batteries are not worth a try, especially if all the existing issues are addressed properly. These batteries could be used in several long-term devices like hearing aids or pacemakers. That way, people don't have to go through traumatizing surgery more than once just to change the batteries, which will then make a huge difference in the way how these batteries are used. These batteries will also be extremely helpful for vehicles in space that need to run for several years because nano diamond batteries are claimed to last more than 28,000 years. It makes sense considering the fact that NASA's iconic space probe Voyager, meant to study the outer solar system when it was launched back in September of 1977, used 3 multi-100-watt radioisotope thermoelectric generators for power. Each generator power output was around 158 watts, which is a lot less energy than what you need to power your household light for a year. So if these diamond batteries, if properly implemented, could power electronics here on Earth, especially the devices that require higher energy. For now, these batteries might debut on a smartwatch sometime this year or by early 2023. If that really happens, you would be wearing a watch with a single battery without ever changing your battery, and your future generations could also use the same watch if everything else is working fine. You cannot deny the fact that batteries run the world, so it's high time to reinvent batteries because today, batteries are also used in our cars, which just accelerates the need offer longer range and faster charging, along with less degradation over time, and more importantly, a lower sticker price will attract several EV buyers.